Now, law of sines can only be applied to certain triangles. If you remember back in geometry, when you did your units or your 1 unit over congruent triangles, you learned about types of triangles, such as side-side-side triangles, side-angle-side, angle-angle-side, angle-side-angle, right? You can only use law of sines when you're given an angle-angle side. Or in reverse, that is SAA. This is when you have an angle, another angle next to it, and a side outside of the 2 angles. This is an AAS triangle. When we're given this type of triangle, we can use law of sines. Also, when we're given an angle, and a side between the 2 angles, an ASA triangle, we can also use law of sines. We cannot use law of sines when we're given side, side, side. Not enough angles. We don't know any of the angles. We can't use law of sines when we're given SAS. Yes. We can't use law of sines when we're given a side, an angle, and a side. Again, not enough angles. So, let's try it. Oh no, let's not try it yet. I want to derive it first. That's right. So here we have a triangle with a height drawn inside of the triangle. Now, if I was trying to do just regular trig to solve for angle A, using sine, what ratio would I set up? What ratio of sides would I set up here? I'm trying to find angle A, and I want to use sine. What ratio of side lengths would I use? Yes. H over B. Yes. I look at the right triangle created by the height. My opposite side is H, and my hypotenuse is B. So that would be H over B. Same thing if I wanted to solve for angle B. What is the sine ratio for angle B? H over A. Now, what is the only thing that both of these trig functions have in common? What variable do they have in common? H. So if I'm trying to compare these two trig functions together, what I'm going to want to do is solve each one for H. I want to get the H by itself. Because I know that in both of these triangles, the H is the same. The height is the same. It's the same value. So on each of these, I'm going to solve for H. How do I get H by itself on the A angle? You multiply both sides by B, so you have H equals B sine of A. What about if I'm trying to get the H by itself on the B angle function? You multiply both sides by little a, and you get H is equal to A times sine of B. Because I know that no matter what, in these two triangles that have the height being the same, because the height is the same, the height is equal, what do I know I can do to these two sine values? Because the height is the same, you can set them equal to each other. Exactly. B sine A has to be the exact same thing as A sine B, because the H's are also the same. So I'm setting B sine of A equal to A sine of B. technically a version of the law of sines. So this is technically a version of the law of sines, but this isn't the easiest way to set this up. Say I wanted my sine values to be alone, right? I don't want the b on it, on the sine of a. I don't want the a on the sine of b. What can I do? Divide by what? So I can divide sine of a by b and divide a sine of b also by b. These b's would cancel. How would I get rid of the a on the sine of b? Divide by a. The a's cancel, and I'm left with sine of a over a. Sine of b over b. This is the law of sines. Now, what relationship would you tell me does angle A have with side A? If I'm looking at their positions on the triangle. They're opposite. Angle A is always opposite from side A. And angle B is always what? Opposite from side B. So all that you do when you're setting these up is you take the sine of an angle over the side across from it and set it equal to a sine of an angle over the side across from it. This is a proportion that we can solve. So let's try it. Example 2 says, given triangle ABC with measure of angle A equals 40 and measure of angle B equals 60 and A equaling 4, solve the triangle. Now when it says solve the triangle, what this means is find all missing values. And round to the nearest thousandths. What do you think we need to do first? Draw the picture. It does not matter what your triangle looks like, and it also does not matter where you place angle A, B, and C. What does matter is if it gives you an angle, a side, across from an angle, you better make sure that that side is directly opposite of the angle you labeled. So it gives us angle A is 40, and it gives us side A is 4. So where should I place the 4? Where should I place the 4 on my triangle? Opposite A. So if I was to name that side with letters, what would the name of that side be? With angle letters. BC. Yeah, I just want to make sure you guys understood where opposite is. It would be that BC line. Now, it's asking us to solve for the measure of angle C. How do we solve for the measure of angle C? Yes, we know that all triangles add up to 180, so we can just subtract 60 and 40 from 180, and we get 80. So angle C is 80 degrees. Now that we know that angle C is 80, do you think it matters which one we solve for first, side B or side C? No, doesn't matter. But let's solve for B first. Does anyone want to help me set up this proportion, this law of sines? So what angle do I have to use in this setup? Not? Okay, yes, you need to use sine of 60 because it's across from what? Side length B. What else do you have to use? A. Because 4 is the only side length they give you. You have to use 4. Therefore, you have to use the angle across from it, which is 40. So now that we have this set up, how can you solve for B? If we have a fraction set equal to a fraction, what can we do to solve? Cross multiply. You can cross multiply here, which means we're multiplying B times sine of 40, and we're multiplying sine of 60 times 4. But then what do we have to do? Is B by itself yet? No. We have to do what? Divide by sine 40. I recommend putting this all in your calculator at one time to avoid rounding issues, rounding errors. So we have, making sure calculator's in degree mode, we have 4 times sine of 60, making sure you end your parentheses there, otherwise it'll take the sine of everything that you type after it, divided by sine of 40. And you get 5.389. And there is no unit in this problem, so we'll just write 5.389. But what else do we need to solve for? We need to solve for C. So we just solved for B. Now let's solve for C. Again, it's easier here to not use the decimal answer, so I'm going to again use angle A and side A as the other side of my proportion. So we have sine of 40 over 4 is equal to what? Yes, sine of 80, because that's the angle across from side length C. And what do we do to solve for C? Cross multiply. Now, as you get better at this, you can recognize that this is going to be C times sine of 40, set equal to 4 times sine of 80, but then we'll have to divide by sine of 40 to get it off of the C. So C is 4 times sine of 80 over sine of 40. If you don't like skipping that in between step, that step we wrote here, that's fine. But I think it's a lot of extra writing, so I just write that. And then in our calculator, we're going to do 4 times sine of 80 this time, divided by sine of 40. Now we get 6.128. Any questions on how to use law of sines? Okay, then you guys try example 3. Okay, so this problem is asking us to solve for the height of this mountain. Now, this surveyor, I know this problem is worded a little bit weirdly because it doesn't tell you that the surveyor's eyes are a distance of 2 meters away from the ground. So whatever we solve for H, to find the true height of the mountain, what do you think we have to do in the end? To get the true height? Add 2. Okay? That's just something that's a little extra we have to do at the end. We just have to remember. Now, does anyone have any ideas for how we could find the height on that triangle? Not yet. You're right, we don't yet. So Ainsley over here recognized that on this triangle, this kind of what I like to call sliver of a triangle, you see this triangle? We can use law of sines if we have an angle, side angle, triangle. Well, right now we don't, but how could we find this angle here? Yes, we know that that angle, that black angle that I just drew, plus the 53-degree angle together add up to be 180. So, what is 180 minus 53? So now, we have angle, side angle. How does that help us? What can we now solve for that will eventually help us solve for h? You could, but how would that help us in the end? Mm-hmm. Any ideas, guys? Yes, you need to have the angle across from the 950 to use the law of sines. So, how do we find this angle right here? Good, and what do you get? It's a small angle, 18 degrees. Now what? What side? Doesn't matter, really. Other side is supposed to be... What? Does it matter whether you solve for the longer, this side or this side, do you think, in the end? You do have to do that. You have to find one of those sides. How? Okay, but do we have a side length on this triangle? Do we have a side length at all? No. So first we have to find one of these sides. It does not matter which. I'm going to find, I think, the bigger side. So I want you guys to use law of sines to find the bigger side on that right triangle there. That x length. Use law of sines to solve for x. So how did you guys set up solving for x? What did you do? Good. Yes. Sine of 18 over the only side we know, the 950, is equal to sine of 127 over x. And then to get x by itself, we cross multiply, and we'll end up with 950 times sine of 127 over sine of 18. Now putting this in your calculator, what did you guys get? Okay. Two 455.217. 2455.217. So now that we know what that long hypotenuse is, how can we solve for h? You can just use regular right triangle trig, right? H is our opposite side, x is our hypotenuse, and our angle is that 35-degree angle. So we're solving for h now. By using O and H means we're using sine of our angle is equal to the opposite side, which is h, over our hypotenuse, which is that 2455.217 number. To get h by itself, we're multiplying both sides by the 2455 number times sine of 35. And we get 1408.255. Right. And like Ainsley just told me over here, we have to remember to add that initial 2 meters that is the height of our surveyor. So we should have gotten 1410.255 meters tall. That's how tall our mountain is.